Hey guys, this would be the performance test for upgraded Nakamichi 680 ZX. So as you remember, I just recently upgraded all capacitors with WIMA, Kemet and Nichicon. So let's see how it's will perform. What I mentioned, that's not all tape types I can calibrate into zero, so it's basically not a problem. I would need like open like an other is like fixed resistors. I just will need to like reduce a little bit there to make sure that it will, I would be able to have a bigger range, but that's it. So far we will be testing. So let's start from calibration process. Okay, so you see it's like a little bit more than 1 decibel off. So when we will switch in source and tape, it will be a little bit off. But for our experiment it doesn't matter a lot. So let me see. Okay, my program, I need to check why it doesn't work. Like everything is connected, so maybe just program itself. Let me restart it. Okay, let's see how the device is. Oh, it's off here. Now we have signal, so see source. Okay, and tape. Source is kinda off a little bit. Okay, so source, tape. You see, -1 decibel. Would be difference, but doesn't matter for us. So let's go to -20. See, it's same 1 decibel difference. It just will go 1 decibel below -20. Okay, let's see, -20 here. And let's do frequency sweep. And it's tape playing now. And it's -20 decibel. Let's see how it will perform. And this type 1, I remind you. You see, 1 decibel below -20. Gets to 10 kilohertz. And it's 15, 16, 17, 18, 19, 20, 22. Type 1. And this is the source. I just switch to the source, so you may see yourself it would be 1 decibel higher. I would say it's staggering performance, exceptional. So we can record like more than 20 kilohertz on type 1 tape. So this is the source. See, it has a little bump, but I tune it up so on the recording we would not be able to hear this bump. Okay, and this was source, and switching back to the tape, and it will go 1 decibel lower. I spent quite a few time tuning it, so it would be able to do that. But in this case, it's astonishing performance. And I've already got request to make a recording with type 1 tape and switch between source and tape. So I will do that. So you see, done. So I believe this would be it for type 1. Now let's go to type 2. Switching to 70 and SX here. Let me check the levels and do calibration. Okay, it's calibrated. It's less than 1 decibel difference between source and tape. Okay, here I have, it's a source, it's tape, source 400 Hz. Like that, so, and it's tape. Let me get a screwdriver to adjust this minor difference. So we would have incredible results. So it's the right channel. I will be adjusting it here. Done. You see how precise. Okay. And on indicator, you see it's precisely -20. I told this indicator is crazy precise. And let's do frequency response. Let's see how it will be different. You see it's about half decibel higher. And it's tape. TDK SA. It's a brighter response from the tape itself. It's on every deck. On Sony I can correct it a little bit with equalization. But all in all, incredible results. Same 20 kHz, easy. Okay, it was type 2, and now let's go type 4. Let me check the levels. Switching to type 4. Recording. Do calibration. Okay, source. It's tape. Need it a little bit. It's a left channel. Okay, and it's be recording, and it's the levels. I believe left, I need to reduce a little bit, like that, and right add a little bit. Okay, let's do one more time. An indicator is, it's generated a little bit different. Okay, so now we have it. And let's do frequency sweep, and it's tape currently playing. You see it's tape, and here is a frequency sweep for Sony XR tape. The same as I showed you before using millivoltmeter. Same flat response I can see here. Okay, this side has a little bit bias off. Let me do a different side of the tape, because I spent quite a few time to have it better, so probably we need like to set levels like here. Maybe it's azimuth issue. I don't like that azimuth doesn't show correctly. Let me make it different. Okay. Now it's good. Now azimuth is good. Let me see if it will change results. But you see a little bit off on the azimuth side, and we can see different frequency response on the high frequencies. Not much, but 2 decibels or even 3 easily. Still pretty good results, you see yourself. And just to be just interested if we can get the different results on the other side of the tape. Okay, now let's see here what we will get. I believe that this auto-azimuth mechanism works pretty well, and we should not see any significant difference. Okay, still a little bit. I like to have it even. Looks like left channel a little bit under biased. Okay. Let me correct it and I will return back to you. Okay, I just corrected. It was like easy fix, 2 minutes. So let's start recording over again. And let's see how it will perform now. Again, see, minus 20 here, and this deviation is recording a control tone sound, which marks the frequency. I'm saying again, it's a tape, so it easily records 22 kilohertz on this tape. And now I will switch to the source, so it's a tape. You see, performance. Now I'm switching to the source, and let's see how it will be different. So source has a little bump between 10 and 15 kilohertz, and that's it. And there is no difference. Okay, switching back to the tape, and you may see, so basically there is no difference between source recording 1 decibel. On the high frequencies it's almost not possible to hear the difference. Okay, I believe I did a great job with this deck. Now I will connect my recorder and we will try recording on all three types to make sure. I will be switching tape and source, and we will hear if there any difference at all. Thank you. See you in the next part.